very pleasant good morning to you all. Welcome back to physics online class. How are you students? I hope you are all safe and good in your home. And last class we have learned the chapter 4 electricity. And we learned about electricity. What do you mean by electric current, electric circuit and components and symbols of the electric circuit. Have you all revised this portion? Yes, very good. Today we are going to learn what do you mean by electric potential and what is potential difference and Ohm's law and resistance of a material and unit of resistance and what is electrical resistivity, etc. First we are going to learn what is electric potential and potential difference. It's a very simple concept. Just listen here. Let us consider the positive charge. Okay. At the point A, here is the positive charge and at infinite distance another positive charge is there. So you all know that the two charges are equal, isn't it? Positive charge. So in between what type of force is there? Yes, very good. Repulsive force. Okay. So, if we have to move the charge from infinite distance to this point, how much amount of work is said to be done? That is called as the electric potential. Okay. So, work done to move the unit positive charge. Unit positive charge means here the charge unit, you all know that coulomb, isn't it? So, 1 coulomb of charge is there at infinite distance. Infinite distance means from this point to it is far away, it is there. Okay, so this charge we are moving from the infinite distance to this point. For that, how much amount of work is said to be done? Why we have to do some work here means in between there is a repulsive force is there. Okay, so for this repulsive force we have to do the work. Then only we can move that charge from the infinite distance to here. Okay. So for that how much amount of work is said to be done, that is called as the electric potential. During this changes there will be the potential energy will be changing. Okay, from infinite distance, if you are bringing the charge from the infinite distance to this point, the energy will be changing. Okay, so electric potential is defined as amount of work done in moving a unit positive charge from infinite to infinity to that point. Okay, against the electric force. Okay, what force here? The repulsive force is there because same type of charge. So okay, so from this we have to move this charge, we have to do some work. That work done is called as the electric potential. Okay, have you all understand? So what do you mean by electric potential? Amount of work done in moving a unit positive charge from infinity to that point against the electric force. Okay. The next concept is potential difference. Okay, so this electric potential and potential difference, there is only one difference only there. Okay, what's that we can see? Electric potential difference between the 2 points is defined as, so like this here also you have to take a 2 charge. Okay, same type of charge, positive charge is there. Okay, Q be the charge at the point of A and another charge is there in the point of B. Okay, so we are moving the charge from this point B to A. Okay, for that how much amount of work is said to be done? Okay, so work done to move the charge from one point to another. So if you want to move the charge from the point B to point A, how much amount of work we have to be do? Okay, against the electric force. Okay, here what force is there? Here the repulsive force is there, isn't it? So against this force we have to move the charge. For that how much amount of work is said to be done? That is called as the electric potential difference between the 2 points. Okay, here we have to say we are moving the charge from infinity to that point. But here we have to say from one point to another. So amount of work done in moving a unit positive charge from one point to another point against the electric force. That only very important. Okay, against electric force we are moving the charge. Okay, so that is called as the electric potential difference. Okay, so let us consider here the charge Q is there. Okay, Q be the charge. Okay, and A and B the 2 points. Okay, so
Here one charge is there, here another charge is there. Okay. So we are moving the charge from the point B to point A. Okay. So for that, how much amount of work is said to be done? W be the work done. Okay. So we can define a potential difference is denoted by the letter V. The potential difference V is equal to work done by charge. Okay. So if you are taking the ratio of work done by charge, we can get what? Potential difference. Okay. Potential difference V is equal to work done by charge. Okay. What's the formula for potential difference? Yes. Work done by charge. Okay. So Q be the charge and W be the work done. Okay. That is the formula for the potential difference. So here VA and VB be the electric potential at the points of A and B. Okay, in the above picture we taken that potential difference at the point A is equal to VA. Potential difference at the point B, it is equal to VB. Okay. Now how to calculate the potential difference? The total potential difference V is equal to VA minus VB. Okay, that is potential difference at the point A minus potential difference at the point B. So here what's the condition? If the potential difference A is greater than the potential difference at B. Okay. So if it is A is greater means we have to subtract VA minus VB. Suppose VB is greater means we have to do this formula VB minus VA. Okay. Potential difference at the point B minus A. Okay. Now we can learn the unit of this potential difference. The SI unit of this electric potential or potential difference is volt. Okay. What's the electric potential unit? Volt. It can be represented by the letter V. Okay. So now we can define what is 1 volt. How to define 1 volt? Yes, we already studied. V is equal to W by Q. Q means charge. W be the work done. Do you know what is the unit of work done? Yes, joule. Okay, the unit of work done is joule. And the unit of charge is coulomb. Okay. Now we can define what is 1 volt. 1 volt is defined as 1 joule of work is done to move the charge of 1 coulomb. Okay. So 1 joule of work is said to be done to move how much amount of charge? 1 coulomb of charge. Okay. So that is called as what? 1 volt. Okay. 1 volt is equal to 1 joule by 1 coulomb. Okay. Here we can see the definition. If 1 joule of work is done in moving 1 coulomb of charge from one point to another. Okay. How much amount of work we are doing? 1 joule of work. Okay. How much amount of charge we are to move? 1 coulomb of charge. Okay. So that defined as 1 volt. Okay. Have you all understand? What is the unit of electric potential or potential difference? Volt. Okay. So this formula we have to use to do the problems. Okay. Keep this in mind. So by using the above formula we can do one problem. Okay. Solved problem number 2 in your book, page number 44. Okay. See the question. The work done in moving a charge of 10 coulomb across 2 points in a circuit is 100 joule. What is the potential difference between the points? What they asked? Work done in moving the charge 10 coulomb. Work done value they given. Okay. And how much amount of charge they given, isn't it? Moving a charge of 10 coulomb. Okay. Work done how much? 100 joule. Okay. 100 joule of work is done to move how much amount of charge? 10 coulomb of charge. Okay. For that, how much potential difference? Okay. So what is the potential difference we have to find? Okay. So here first given data you can write charge Q is equal to 10 coulomb. Okay. Charge Q is equal to 10 coulomb. Next, work done how much they given? 100 joule. Okay. W is equal to 100 joule. What we are going to find? Yes, potential difference. So V be the potential difference we are going to find. Have you remember the formula? Just now we studied, no? Yes. V is equal to W by Q. Work done by charge. Okay. So V is equal to W by Q. So here what we can substitute for W? Yes. W what value is there? 100. Divided by charge what value is there? 10. Okay. So if we are dividing, what you will get? Yes. The amount of this potential difference is how much? 10 volt. Okay. So V is equal to 10 volt. We have to write the unit. Okay. So V is equal to 10 volt. Next we are going to learn one important question, okay, in this electricity lesson, Ohm's law, okay, very very important, okay. If you are going to 12th standard, there also you will learn this, okay. So who proposed this, who formulated this law? A German physicist, George Simon Ohm, okay. Who proposed this? A German physicist, George Simon Ohm. So this Ohm's law tells the relation between voltage or potential difference and I, current, and or be the resistance, okay. So the Ohm's law tells the relation between the potential difference and the current and resistance, okay. Here just to see this circuit, a nichrome wire is connected in between this gap XY. Along with that, parallelly it will be connected the voltmeter, and seriously it will be connected ammeter and battery, and here is the key, and RH be the rheostat. You all know that rheostat, it is used to change the what? Resistance, okay. So variable resistance, okay. If you want to change this voltage, we can use this rheostat, okay. Rheostat, it is used to change the resistance in the circuit, okay. And here listen, let us consider battery, 5 volt battery is connected here, okay. Now here the 2 ampere of this current, it is flowing, okay. Just you can see this example, okay. Now we can see that potential difference here, okay. By using this voltmeter, we can measure the potential difference of this wire, okay. So here if you are increasing this voltage, what will happen? The current also will increase. For example, instead of this 5 volt, if you are giving a 10 volt, what will happen here? The current also will be increased, okay. Double, it will be maybe 4 ampere, okay. If you are increasing the voltage, current also will be increases, okay. This relation only, it is called as the what? Ohm's law, okay. So the Ohm's law states that at a constant temperature, the steady current I flowing through a conductor is directly proportional to the potential difference between the two ends of the conductor. Listen, at a constant temperature, a steady current I flowing through the conductor is, that is, current increases means potential difference also will be increases. That is the meaning of directly proportional, okay. At the particular temperature, we are giving that current, steady current I flowing in the conductor. It is directly proportional to the potential difference between the two ends of the conductor. So here we can measure what? That in between the two ends of the conductor, we can measure the potential difference, okay. The current is directly proportional to the potential difference, okay. If you are increasing the current, the potential difference also will be increases, okay. That is the meaning of directly proportional. Here we can see that formula I proportional to V, okay. Current is directly proportional to the potential difference, okay. Now if you are taking this proportional, we can write with one constant, okay. That constant we have to write, that is 1 by R, okay. So listen, the constant 1 by R. So I is equal to 1 by R into B, okay. I is equal to 1 by R. So this 1 by R, okay, this R denotes resistance, okay. This R denotes resistance, okay. Now if you are by using this expression, we can write what is V. V is equal to what? I into R, okay. Take this R here, so I into R. V is equal to potential difference is equal to current into resistance. Potential difference is equal to current into resistance, okay. And from this expression, I proportional to V, and I by V is equal to a constant, okay. That constant only, it is called as the resistance, okay. Now by using this formula, we can do the problems, okay. So because they will ask to find current, and they will give the potential difference and resistance, okay. Any two value they will give, you can find the remaining one, okay. So this three formulas also we can use, okay. V is equal to I into R, and if they asked to find current, I is equal to, how to write? V by R, okay. V divided by R. And if they are asking to find the resistance, what you will do? Yes, V divided by I. Voltage by current is equal to resistance, okay. And current is equal to voltage by resistance, okay. So in this by using these variables, we can find the current, potential difference and the resistance, okay. It's a very important definition. Okay, we can see once again at a constant temperature, the steady current I flowing through the conductor is directly proportional to what? Potential difference between the two ends of the conductor. So there is R denotes a constant for a given material at a given temperature, and this R is known as what? Resistance. Okay, R is called as the resistance. Okay, now we can draw the graph between this current and volt. Okay, if you are drawing this graph between current and resistance, current and voltage, we can get the straight line. Okay, so this graph tells the relation between the potential difference and the current. Okay, you have to plot this voltage along the x-axis and the current along the y-axis. Okay, and here what this represent means, the straight line represent if you are increasing the voltage, the current also increases. Okay, if you are increasing the voltage, the current value also will be increases. That's why we can get this graph. Okay, so Ohm's law, what Ohm's law states that the current I is directly proportional to the potential difference. Okay, I proportional to V. Okay, for that we can draw this graph. Okay, so this straight line represents the current, voltage increases, current also will be increases. Okay, or the current increases, voltage also will be increases. Okay, now we can see what is the resistance of a material. Okay, all the type of material or a conductor, there will be the resistance. Okay, so resistance means what? It's the property to oppose the flow of charges and hence the passage of current through it. Okay, the property to oppose, this word is very important. Okay, the property to oppose the flow of charge and hence the passage of the current through it. Okay, if it is a good conductor means there will be the less resistance. Okay, and if it is a insulator means there is a what? Resistance value is more. Okay, resistance value is more. Okay, so resistance of a material is the property to oppose the flow of charge and hence the passage of current through it. Okay, so here you all know that if it is a conductor means there is a number of free electrons, more number of what is there? The free electrons are there. Okay, free electrons are there, more number of free electrons are there in the conductor. Okay, so here resistance value will be very less. Okay, resistance is less for a conductor. The same time, if it is insulator means there is no free electrons. Okay, if it is insulator means there is no free electrons and the resistance is more. Okay, so resistance of a material is the property to oppose the flow of charge and hence the passage of the current through it. Okay, and this resistance value is different for different material. Okay, so you all know that copper is a good conductor of electricity and nichrome, aluminium, these are the good conductors. Okay, and plastic, rubber, wood, these are the bad conductors of electricity. Okay, and they are called as the insulators. Okay, they are called as the insulators. Now we can learn the definition of resistance. Okay, how will you define the resistance? So resistance, it gives the ratio between the potential difference across the two ends of the conductor and the current flowing through it. Okay, so resistance is equal to the ratio of the potential difference. V be the potential difference. Okay, and I be the current. Okay, if you are taking the two ratios, okay, two values, we can get what? Resistance. Resistance is equal to the ratio between the potential difference V and the current through it. Okay, that's the definition of resistance. Okay, now what's the unit of resistance? Yes, the SI unit of resistance is ohm. It can be represented by the symbol ohm. Okay, this is the symbol. It is a Greek symbol. Okay, the ohm, it can be represented by the symbol like this. Okay, now we can define what is 1 ohm. Okay, how will you define 1 ohm? Again, once again you have to remember this formula. R is equal to V by I. Okay, so now you all know that the unit of the current is ampere. The unit of this potential difference is volt. Okay, and the unit of resistance is ohm. Now we can define what is 1 ohm. If a current of 1 ampere, see 1 ampere current flows through it, when the potential difference is 1 volt means, okay, 1 ampere of this current is flowing through a conductor. That time the potential difference how much? 1 volt means the resistance is equal to 1 ohm. The resistance is equal to 1 ohm. Okay. So if a current of 1 ampere flowing through it, when a potential difference of 1 volt is maintained across it, means across the two ends of the conductor is 1 ohm. Okay. So 1 ohm is equal to 1 volt by 1 ampere. Okay. How to define? Resistance unit is ohm. So 1 ohm is equal to potential difference what? Volt. Okay. Unit of potential difference what? 1 volt by current unit is ampere. So 1 ampere. So 1 ohm is equal to 1 volt by 1 ampere. Now we are going to do one problem by using this Ohm's law. Okay. Page number 46. Problem number 3. Calculate the resistance of a conductor through which a current of 2 ampere passes when the potential difference between its end is 30 volt. Okay. So we have to calculate the resistance of the conductor. How much amount of the current? Yes, 2 ampere current. And the potential difference developed is 30 volt. Okay. How will you calculate the resistance? First you write the given data. Current I is equal to 2 ampere. Potential difference V is equal to 30 volt. And what we are going to find? Yes, resistance R. So what's the Ohm's law formula? Have you remember? R is equal to V by I. Okay, potential difference by current. R is equal to V by I. Okay, and you have to substitute all these values and we can get the resistance value. So V value what they given? Yes, 30. So 30 divided by what is the value of I? 2. Yes, 30 by 2. So if you are dividing, what will get? Yes, 15. Okay. So the answer is 15 ohm. The resistance value is 15 ohm. Okay. Next we are going to learn what is electrical resistivity and electrical conductivity. Okay. First one, electrical resistivity. You all studied. Now what do you mean by resistance, isn't it? So the resistance of any conductor is directly proportional to the length of this conductor. Okay, directly proportional to the length of the conductor. Resistance is directly proportional to length. Okay, so if there is a length it is increases means the resistivity value also increases. Okay, so when the length is increases, the resistivity also will be increases. Resistance is more. Okay, and it is inversely proportional to the area of the cross section of a conductor. Okay, the same length increases means resistance will be increases, but the area of the cross section of a conductor is more means resistance value is less. Okay, so area is more means resistance is less. Okay, so R proportional to 1 by A. What's the meaning of inversely proportional? 1 by area. Okay, so R is directly proportional to length of the conductor and resistance is inversely proportional to area of the cross section of a conductor. Now you can combine these two. You can write R proportional to L by A. Okay, so R is directly proportional to length and inversely proportional to area of the cross section of a conductor. Okay. Now, if you are taking this proportionality, next line what we'll write? We'll write with one constant, isn't it? Here you have to take that constant of proportionality is denoted by rho. Okay, the constant of proportionality is denoted by what? Rho. So, next line we have to take this proportional and can write equal. R is equal to rho L by A. What is this rho? Is a constant of proportionality and this is called as the resistivity of a material and the rho is called as the resistivity of a material. Okay, so constant is called as the electrical resistivity or another name also there, that is specific resistance. Okay, electrical resistivity or the specific resistance. Okay, now we can take this formula. Now electrical resistivity rho is equal to RA divided by L. Okay, take this A here and L it will become in the denominator, isn't it? So we can get this formula for the electrical resistivity. Rho is equal to RA by L. Okay, just take this R A here and L will become in the denominator. Okay, so rho is equal to R A by L. That is the formula for the electrical resistivity. Okay, what's the formula for electrical resistivity or specific resistance? Rho is equal to R A by L. Okay, so rho is equal to R A by L. Now suppose this two value is 1, that is area of the cross section of a conductor is 1 meter square and the length of this conductor is equal to 1 meter, means what's this value of rho? Rho is equal to R. Okay, because this two values is equal to 1. Okay, area of the cross section is 1 meter square and length of this conductor is 1 meter. Therefore, the electrical resistivity rho is equal to R. Okay, electrical resistivity is equal to resistance. Okay, electrical resistivity is equal to what? Resistance. Now we are going to learn the definition of electrical resistivity. Okay, you all studied now electrical resistivity means what, isn't it? Electrical resistivity will be directly proportional to length of this conductor and inversely proportional to the area of the cross section of a conductor. And we also learned that formula also. Okay, what formula we learned? Yes, electrical resistivity rho is equal to R A by L, isn't it? Electrical resistivity rho is equal to R A by L. Now we can learn the definition. Resistance of a conductor of unit length and unit area of the cross section. The electrical resistivity is defined as the resistance of a conductor. Okay, so electrical resistivity is defined as rho is equal to R, the resistance of a conductor. What is the condition here? Yes, length of this conductor is 1 meter and the area of the cross section is 1 meter square. Okay, so in the conductor we have the length 1 meter and the area of the cross section is 1 meter square, means electrical resistivity will be equal to the resistance. Okay, electrical resistivity is equal to the resistance. Okay, and this unit of this electrical resistivity is ohm meter. Okay, the unit of electrical resistivity is ohm meter. Here one example they given, nichrome is a conductor with the highest resistivity. Okay, because nichrome wire is a conductor. What is that resistivity value? That is the highest resistivity value is there for the nichrome. Okay, nichrome is a conductor but it has the highest resistivity. What's the value? 1.5 into 10 to the power minus 6 ohm. Okay, what's the electrical resistivity of a nichrome? 1.5 into 10 to the power minus 6. Okay, note it for this one word question. Okay, and this is the reason it is used, the nichrome wire is used in making the heating elements. Okay, the heating elements, for example the iron box and all there, no, there is a nichrome is there. Okay, so because it has the highest resistivity value. Okay, so it is used to making the heating elements. Now we are going to learn what is conductance and conductivity. Okay, just opposite to the resistance only, that is called as what? Conductance. Okay, and what do you mean by conductivity? Okay, opposite to resistivity is called as what? Conductivity. Okay, for a good conductor the conductivity value and the conductance is more. Okay, and then for insulator the conductance value is less. Okay, so here we can learn what is meant by conductance and conductivity. It's a property of a material to aid the flow of charges and hence the passage of current in it. Okay, the property of a material to allow the charge, okay, flow of charge easily will be takes place in that type of conductors. Okay, that property is called as the conductance. Property of a material to aid the flow of charges and hence the passage of current in it. Okay, so we can define, it is defined as the reciprocal of the resistance. Okay, just opposite to the resistance only, that is called conductance. Okay, so it is defined as the reciprocal of the resistance. Okay, so the conductance we can define the value, define that letter is G. Okay, conductance G is equal to 1 by R, reciprocal of resistance. Okay, conductance G is equal to the reciprocal of resistance. Okay, 1 by R. Okay, now we all know that what is the unit of this resistance? Ohm. Okay, so what is the unit of conductance? Yes, 1 by ohm. So that is what? Ohm power minus 1. Okay, ohm inverse. Its unit is ohm power minus 1, or we can write mho. Okay, just reverse we can write mho. Okay, mho. The unit of this conductance is ohm power minus 1, or it's denoted by mho. Just now we learned what is the conductance definition. Okay, that is the reciprocal of the resistance. Now we are going to learn the definition of electrical conductivity. Here the reciprocal of electrical resistivity of a material is called as what? Electrical conductivity. Just opposite to electrical resistivity. That is, the reciprocal of electrical resistivity of a material is called electrical conductivity. Have you remember what letter we denoted the electrical resistivity? Electrical resistivity denoted by rho, isn't it? Here electrical conductivity is represented by sigma. Okay, sigma is equal to 1 by rho, reciprocal of electrical resistivity. So electrical resistivity is denoted by rho, reciprocal, that's a 1 by rho. Is called what? Electrical conductivity. Sigma represent electrical conductivity. Electrical conductivity is equal to 1 by sigma. Okay, sigma is equal to 1 by rho. Okay, reciprocal of electrical resistivity of a material is called as the electrical conductivity. Sigma is equal to 1 by rho, and its unit is ohm power minus 1 and meter power minus 1. Okay, so you all know that electrical resistivity, what's the unit we studied? Yes, ohm meter. Okay, ohm meter. Now the unit of this electrical conductivity is, just you have to take that inverse. Okay, ohm power minus 1, meter power minus 1. Or we can write, instead of this ohm power minus 1, we can write what? Mho, mho, and meter power minus 1. Okay, so reciprocal of electrical resistivity of a material is called as what? Electrical conductivity. Okay, the next one. This electrical conductivity is a measure of its ability to pass the current through it. Okay, if you know this value of electrical conductivity of a material, we came to know that how much amount of this current, okay, the ability to pass the current through it. Okay, so electrical conductivity is a measure of its ability to pass the current through it. Okay, because you all know that different types of materials are there. Okay, some are good conductors. Okay, and good conductors example copper, aluminium. Okay, is a good conductor of electricity. Okay, and some are the non-conductors or bad conductors, and also called as what? Insulators. Okay, example glass, wood, rubber, etc. These are the non-conductors or insulators. Okay, non-conductors or insulators. Okay, now we can see how that conductivity is there in the conductors. See, conductivity is more in the conductors than insulators. Okay, conductivity value is more for the conductors than for insulators. Okay, insulator there will be there is no free electrons are there, so it won't be conduct the electricity. But conductors, there will be number of free electrons are there to conduct the electricity. The conductivity is more for conductors than insulators, but the resistivity is less in the conductor, okay, than insulator. For the insulator only resistance will be more, or resistivity is more for the insulators. So here the resistivity is less for the conductors than insulators. Okay, conductivity is more for conductors and resistivity is less for the conductors. Okay. Now we are going to do this problem number 4. Okay, solve problem number 4. In your book, page number 47. Read the problem. The resistance of a wire of length 10 meter is 2 ohm. If the area of the cross section of the wire is 2 into 10 to the power minus 7 meter square, determine its resistivity and conductance and the conductivity. Okay, so length of this wire they given and resistance value is here. So we are going to find the resistivity, conductivity and conductance value. Okay, first you have to write the given data. L be the length of this wire, how much? 10 meter, and R be the resistance, how much? 2 ohm, and A be the area of the cross section of a wire, how much they given? 2 into 10 to the power minus 7 meter square. We are going to find resistivity rho and the conductance G and the conductivity sigma. You all know that formula for the resistivity? Yes, Yes, rho is equal to RA by L. What's the formula for resistivity? Rho is equal to RA by L. Here R value is here 2. 2 into area of the cross section. What's the value? 2 into 10 to the power minus 7. Okay. Divided by 10. Okay. Just you have to cancel it. 1, 2 is 2. Here what? 5, isn't it? So 2 divided by 5. So divide it. What will get? Here 2 is there. Here 5 is there. So 0. Here 0 you can add. Now 4. 5 so 20. Okay. So here we can get 0.4 into 10 to the power minus 7. Okay. Now we can change this into whole number by keeping the decimal here. So it will become minus 8. Okay. So 4 into 10 to the power minus 8 ohm meter. This is the resistivity value. Okay. Now next what we are going to find? Conductance. Okay. Conductance is the reciprocal of the resistance. So conductance here represent the letter G. G is equal to 1 by R. R value already they given in this problem 2 ohm, isn't it? So 1 divided by 2. Just see here resistance value is 2. So conductance G is equal to 1 by R. So it is equal to 1 by 2. Okay. So 1 by 2 what's the answer? 0.5. The unit of this conductance is mho. Otherwise ohm power minus 1. Okay. So 1 by 2 is equal to 0.5. Next we are going to find conductivity. Conductivity can represent the letter sigma. Sigma equal to 1 by rho. Okay, 1 by rho. Rho means what? The resistivity, isn't it? So resistivity we already found that value. What's that? 4 into 10 to the power minus 8 ohm meter. Okay, so 1 divided by 4 into 10 to the power minus 8. 1 by 4 what's the value? Yes, 0.25, isn't it? 0.25 into 10 to the power minus 8 mho meter power minus 1. The unit of this conductance is conductivity is mho meter power minus 1. Okay, this is the answer. Okay, 0.25 into 10 to the power minus 8 mho meter power minus 1. Okay, so you have to do all these problems in your problem note. Okay, already you are writing all the questions, exercise problems and all there in the note. No, the same note you have to copy down these problems also. Okay, you have to mark this question in your book. Okay, Roman letter 7, question number 1. Define electric potential and potential difference. First question, Roman letter 7. First question, page number 44. And question number 3, state Ohm's law, that is page number 45. Mark it and distinguish between the resistivity and conductivity of a conductor, page number 46. So take page number 44. First question, the electric potential at a point is defined as amount of work done moving unit positive charge from infinity to that point. Just underline that, infinity to that point against the electric force. This is the definition of electric potential. Then next, electric potential difference. Okay, that one. The electric potential difference between the 2 points is defined as the amount of work done in moving unit positive charge from one point to another against the electric force. This is the definition of electric potential difference. And you can mark this formula for the potential difference. V is equal to W by Q. Next question. It's not a book back question, but you have to mark here. Define 1 volt. The potential difference between the points is 1 volt. If 1 joule of work is done moving 1 coulomb of charge from one point to another against the electric force, 1 volt is equal to 1 joule by 1 coulomb. Just mark this unit of electric potential difference is volt. Now take this page number 45. Already I told Ohm's law. According to Ohm's law, the constant temperature steady current flowing through a conductor is directly proportional to the potential difference between the two ends of the conductor. I proportional to V. I by V is equal to constant. Up to that you can mark. Okay. And here is the formula. V is equal to I into R. It's very important for doing the problems. And next one, what is the resistance of a material? Okay, just read this paragraph. Here they given what is resistance. Mark this question. What is resistance? Resistance of a material is the property to oppose the flow of charges and hence the passage of current through it. It is different for different material. This is the formula for the resistance. R is equal to V by I. Now define resistance. Here you have write what is resistance. Next you can write define resistance. You can mark here the resistance of a conductor can be defined as the ratio between the potential difference across the ends of a conductor and the current flowing through it. Next question, define the unit of resistance. Here the SI unit of resistance is ohm. It can represent the symbol. This mark it. And next page, resistance of a conductor is said to be 1 ohm. If a current 1 ampere flows through it when the potential difference of 1 volt maintained across it. 1 ohm is equal to 1 volt by 1 ampere. Okay, this problem already we discussed. Okay. Next, the difference between electrical resistivity and conductivity is there. The book back question. So you have to write what is electrical resistivity and what is you have to divide into 2, and you can write the tabular column the electrical resistivity one side and electrical conductivity. Okay, and write these points and the formulas. Okay. Here is the formula for this resistivity. Rho is equal to Ra by L. It is called as the electrical resistivity or specific resistance. Here just you have to underline that. Okay. The resistance of a conductor directly proportional to length L and inversely proportional to area of the cross section. So R proportional to 1 by A, R proportional to L. So by using this we can write R is equal to rho L by A. From this we can derive the formula for rho is equal to Ra by L. If the value of A is equal to 1 meter square and the length is equal to 1 meter means resistivity R is electrical resistivity rho is equal to R. Then here conductance and conductivity is here. Conductance of a material is the property of a material to aid the flow of charges and hence the passage of current through it. And next one, the definition is there. The electrical conductivity is defined as reciprocal of the resistance. Conductance means reciprocal of resistance. First definition, what is conductance? It is defined as reciprocal of resistance. It can be represented by the letter G. G is equal to 1 by R. Unit also mark it. Here given the definition of electrical conductivity. Reciprocal of electrical resistivity of a material is called electrical conductivity. Sigma is equal to 1 by rho. Its unit is ohm power minus 1. Meter power minus 1. Here this is the definition of electrical resistivity. Okay, electrical resistivity defined as the resistance of a conductor of unit length and unit area of the cross section. Unit is ohm meter. Just more to, do you know this paragraph? Mark it. Nichrome is the conductor's highest resistivity and this value is equal to 1.5 into 10 to the power minus 6 ohm meter. And today's homework. First question, define electric potential. Define electric potential difference. This is page number 44. Third question, state Ohm's law. It's given in page number 45. And distinguish between resistivity and conductivity. It's page number 46. Next one, define 1 ohm. Page number 46. And define 1 volt. It's given in page number 44. And the last one, define resistance. Page number 45. Okay, this is 7 question. You have to learn and write in the note. Okay, thank you students.